Problem 1. The purification of hydrogen gas by diffusion through a palladium sheet was discussed in section 5.3. Compute the number of kilograms of hydrogen that pass per hour through a 5 mm thick sheet of palladium having an area of 0.2 square meter at 500 degrees centigrade. Assume a diffusion coefficient of 1 into 10 to the power minus 8 square meter per second, that the concentrations at the high and low pressure sides of the plate are 2.4 and 0.6 kilogram of hydrogen per cubic meter palladium, and that steady state conditions have been attained. So let's see what is known in this question, but before that we know that the diffusion flux is equal to minus d times dc over dx, or we can also write it as minus d into delta c over delta x, if we assume that the change in concentration with respect to the thickness is linear. So then we can also write it as minus d into c2 minus c1 over x2 minus x1. Okay, so x2 minus x1, which is simply delta x. So in this case we already know that the diffusion coefficient is given as 1.0 into 10 to the power minus 8 square meter per second, and the concentrations at the high and low end are also given as, okay, concentrations at high and low pressures are 2.4 kilogram per cubic meter, it is for C2, 2.4 kilogram per cubic meter, and C1 is 0.6 kilogram per cubic meter. Okay, so from this we can find the value of J, and then of course delta X is the 5 millimeter thick sheet, so delta X is equal to 5 millimeter, which we can also take into meters, 5 into 10 to the power minus 3 meter. So J will be equal to minus D, the value of D is 1 into 10 to the power minus 8 multiplied by delta C, which is 2.4 minus 0.6 kilogram per cubic meter divided by 5 into 10 to the power minus 3 meter, that is equal to, so this value will be equal to 3.6 into 10 to the power minus 6 kilogram per square meter second. Okay, so this value can be converted into the total mass by this formula. J is equal to M. M is the mass, total mass, and area, and then the time. So J is basically the mass passing per unit area and in a unit time. So from here we can find mass, the value of mass, okay, which is actually asked over here. Compute the number of kilograms of hydrogen that pass through 1 hour. So in this case we know that the area is 0.2 square meter, and time is 1 hour per hour. Okay, so mass per hour we need to find. Time is 1 hour, which is equal to 3600 second. So if we just input these values over here, the value of G of J is 3.6 into 10 to the power minus 6 is equal to m divided by A is 0.2 into 3600. So from here we can find the value of m, which will be equal to 2.59 into 10 to the power minus 3 kilogram. So maybe it's better to convert it into grams, so multiply it by 1000, so it will be 2.59 gram.